History has shown that people have lost keys more than keys have been stolen. And so protecting people and companies, organizations from errors, from operational daily errors that can be many, that can manifest themselves in various ways. That is kind of the first mission of this company, is to bring the best practices of SaaS to streamline and standardize secure key management as much as possible. We do think that, especially for incoming application developers, interacting with an API, a friendly and familiar API, is much more manageable, hence more secure than dealing with the Web3 complexity. Revolut, if banks, if social apps, TikTok maybe tomorrow, etc., want to expose users to wallets, to crypto, digital assets in general, you need to design systems, architecture them in a way that is going to be built for scalability.
At no point is there one private key share, so which actually is your wallet. At no point do we have one private key in one place, neither at creation time of the wallet, neither at signing time.
Today we are joined by Chris and Thibault from Dfns to go through their architecture in detail. I will ask Chris and Thibault to introduce themselves, introduce a little bit about Dfns, about their MPC architecture, why they started the company, why they've built what they've built, what are the trade-offs that they've done, and we'll get into a little bit more detail on that. But let's first go to Chris and Thibault to introduce themselves. Please.
Thanks, Anurag.
Thank you.
Yeah. So Chris, co-founder and CEO of the company. We started this company 3 years ago in 2020. And the most vanilla way to put it is it's a KMS, and we'll dig into why it's more than just a KMS.
I'm Thibault, and I'm a software developer here at the company, focusing on the API side and the infrastructure.
So yeah, it's not we don't get to disclose the whole architecture a lot every day, because we're a very I would say discrete brick in the stack of many applications out there in Web3. But we're happy to do it with you, Anurag, so thanks.
Yeah, thanks guys, and thanks Thibault for taking the time out. I know we've been doing this.
Because this is ETHCC right now,
Exactly.
Do you wanna explain a bit about what we do?
Yeah, sure. Let's start with a high-level overview. So I can maybe draw a first diagram. So let's say these are users, right? All using apps, and one app from a company, can be Revolut, let's say. This app will connect to our API, the Dfns API app and users. Sorry if I write poorly. It will go through a bunch of microservices that we can go through with Thibault, all the way to our KMS, which is where the MPC protocol, the threshold signatures, will operate in a peer-to-peer network that is, for now, and has been since for the past 3 years, off-chain, but with interesting security and trust guarantees. So that's kind of this architecture that basically does not give out private key shares from the wallet to users on their phone, but separates the key shares by the microservices and the API, actually responds to a couple of architectural assumptions, right? The first of which is that we started this journey, we started this company by an observation. Clarisse, the CEO, who's not in this video today, but she's been working in investment banking for 10 years. And she was doing the ICO of a blockchain name service company called Starname, IOV at the time. chilling a coin. An ICO is always a very hectic moment, and investors wanted to invest in that ICO. But at the final ultimate moment of handing over private keys and saying, you know, careful, do not lose them, because otherwise you lose access to your funds, they would get cold feet and withdraw their intentions to invest. And so all the efforts that she had done during the summer went to trash. And so the reason being the compliance, right? Like those investors were not able to wrap their minds around the fact that they would actually hand over ledger nanos or whatnot to traders that could go away with the funds, etc. So that was like 2019. You know, we were still at that time, in that epoch, we were still at that level of the norm was still like hardware in your hand, right? Almost. And so she literally thought like, hey, this. We were, I don't know, like today we are at 20,000 developers, 25,000 developers in Web3. As a good number to remember is that we have like 1 million developers in fintech, we have 5 million developers in banking. So we're really still at in the early days of all of this. And the key management it's as blunt and vanilla, as boring as it is complex. And history has shown basically, and this is kind of the first assumption, right? History has shown that people have lost keys more than keys have been stolen. And so protecting people and companies, organizations from errors, from operational daily errors that can be many, that can manifest themselves in various ways. That is kind of the first mission of this company, is to bring the best practices of SaaS to streamline and standardize secure key management as much as possible, especially to startups, scale-ups that don't have the resources or the time to manage this in a secure way. That was number one. The other assumption is that we do think that, especially for incoming application developers, interacting with an API, a friendly and familiar API, is much more manageable, hence more secure than dealing with the Web3 complexity, which also kind of interacts with blockchains. We have a bunch of nodes, that are attached to this whole system. So it's not only about the keys, right? But we do think that manageability is a key, a virtue, a benefit that is important to onboard new application developers from Web 2 to Web 3, as we usually say. And the third is perhaps that we do think that, the microservices help a lot with scalability, with speed signing speed, keygen speed, cost efficiency. We're very much harnessing the power of cloud here, right? And we're simply this, I would say, cryptographic layer, orchestration layer for keygen and signing on top of cloud beasts and secure enclaves. We'll touch on that later, but that is another assumption, is that if Revolut, if banks, if social apps, TikTok maybe tomorrow, etc., want to expose users to wallets, to crypto, digital assets in general, you need to design systems, architecture them in a way that is going to be built for scalability. So those are a couple of architectural assumptions behind this simple diagram, but maybe I'm missing something.
No, I mean, you said many things. Maybe we can, I guess, for more people to like understand what we do, the simplest way to put it is like we're a wallet manager, we're a wallet provider, right? Like just like MetaMask is, just like Ledger are. So the difference is, if I had to draw something, do you have
this one?
Yeah. So, like, the difference is that we Dfns chose one specific technology to do provisioning wallets and storing them securely and everything. For example, like MetaMask, their stand is your key, your wallet, like is you have your keys as a user in in the browser, and when you create a wallet with MetaMask, you end up having, I'll just represent it with like a key like this, a private key, which is your wallet basically in your browser. With Ledger, you have a hardware like an HSM, basically a USB key, and that's where the private key is. With Dfns, the private key, so here you have one key. With Dfns, the key is stored and is kept and is created in the cloud. What it means is that it's not, it's here with MetaMask or Ledger, if you lose your Ledger, or if you break your phone or break your laptop, you lose your key, right? With Dfns, what happens is that we distribute a key. We use MPC technology, so multi-party computation technologies, to distribute a key into key shares, and we host all of those key shares into a signing network, which is in the cloud. So like you can see, like imagine, so this is the cloud, and you have several, let's call them signing nodes, and this is a signing cluster, and your wallet is actually going to be what we call key shares. So it's like pieces of keys in each of these nodes, and together they form a wallet. And we use threshold signature scheme technology, so it's called TSS, so MPC TSS. And what it does is basically you can say, let me create a wallet with a configuration of like 3 out of 5. Well, here I only have 4, like, so let me make a fifth node. 3 out of 5, meaning that you have like 5 key shares, and you need 3 of them to actually sign something. So to actually make a transaction on the blockchain, sign a transaction on the blockchain, so to make a transaction. And the difference with all these technologies, one of the main differences is that at no point is there one private key share, so which actually is your wallet. At no point do we have one private key in one place, neither at creation time of the wallet, neither at signing time, to sign transactions. And that's the particularity of like MPC and TSS, is that at no point in time, like when a signature request comes in, there's all these communications between those nodes, so that eventually a signature comes out of it. And that's a signature request, and that's a G. But at no point is the private key recomposed in one of these nodes, which removes the single point of failure of like having at one point in time one private key share, which is the most important thing that you want to safekeep, which is your wallet and your funds, and that's what we use. So that's the difference between these things.
Yeah.
Happy to deep dive if you have like other questions around how we do it, like how we, depending on what you guys want to know.
Yeah. So perhaps before getting into the deep dive, right? Like, can we think of a simpler mental model for regular users, right? Like, I mean, maybe like generally we call it like explain like I'm 5, right? Like. Okay. So if you were to do that, like, how would you explain?
How to use Dfns, or how Dfns works behind the scenes? How Dfns works? Okay. So I can try to pretend you're 5 here, see if that works. So I probably won't be the best person to explain you in detail, like, or maybe in the simplest way, how threshold signature scheme works. But if you're 5,
let's take the example if you're familiar with Harry Potter.
Yeah.
And
Horcruxes?
Horcruxes. So
Okay.
If you.
Okay. Well, I mean, yeah. Basically, so let me draw what I had here.
Well, actually, it's not you can't use Horcruxes to explain NPC because you can use that to explain what Shamir secret sharing is, but we like the beauty of NPC is that
So
I can show you.
TSS.
Okay. So I can show you like so here I have five signing nodes. So imagine 5 servers throughout the world. Like one is in Sydney, one is in Singapore, one is in whatever. And someone asks, "Hey, can I get a wallet?" So what we do behind the scenes is like make all of those servers that are really all of these servers are in different places and they're all very secure. They have ways to communicate between them in a very secure way. No one else can, only them can discuss between them. So they form what we call a signing network, which is like a private network. And so they just talk with one another. So for example, there's the coordinator in the middle, and the coordinator receives a request to create a key, to create a public-private key pair, so a wallet basically, and he sends this request to all of each of the node, and he basically coordinates these nodes talking with one another. And so these nodes are going to start talking with each other for a while, like several times. And after a while, after they stop talking to each other, the end result is that each one of them have created a key share, so a piece of key. And so each of these key shares are like different pieces of keys. And this signer 1, has never seen or like cannot reproduce the key share of signer 2. Like it's impossible cryptographically. So now all these key shares are tied together just because they represent one wallet. But they live in different places, and signer 1 cannot access the rest of the key shares, cannot guess it, and that's it. So that's how a wallet creation works. Now, as a user, you don't even care. Like you might not even care about this. You might just know, oh well, it's more secure than having your key at home on a Ledger Nano or whatever. But like maybe you don't care about this. What you're going to see is just, hey, I'm a user. I'm just requesting Dfns to generate me a wallet. We do the whole thing behind the scenes, and we give you back a wallet. And now, as a user, again, you want to start doing some transactions on Ethereum, for example. And so you request to, hey, Dfns, can you sign? I want to sign some transactions and make a transaction on Ethereum. And so we, again, make those signers talk with each other so that it eventually generate a signature of a payload, so of a transaction. And with that signature, now you can take that as a user, or like within our product, like we can take the signature and emit it on the blockchain, which basically creates a transaction on Ethereum, for example.
Okay.
Yeah.
Okay, makes sense. So I think, so basically...
one thing I didn't mention though is maybe which kind of like relates to your question about Horcruxes or stuff, like is that, so since the fact that we're using TSS, threshold signature scheme, like I said before, means that you can say, okay, I only need 3 key shares out of all those 5 ones to generate a signature. And the good thing about this is, and you can choose the setup on creation time, but once it's chosen, it's fixed. And from now on, like if 2 of these nodes go like crash, like this data center crashes, this one crashes, you still have like 3 nodes available to be able to make a signature, which means that you can lose. You have some failure or resilience right here, which is one of the advantages of TSS.
Yeah. But unlike Horcruxes, MPC allows this not to be reassembled.
Yes. Maybe I can, which is the difference with Shamir secret sharing, which is basically splitting keys. You have key shares, but then when you want to sign, basically those like Horcruxes come together to sign. But at the moment where they come together, they form one key, which is the thing that you don't want to show or to anyone, even the server.
Yeah.
So that's the difference with.
Maybe to double click on that, you have a. You showed MetaMask, you showed Ledger. Maybe if we're going to continue chronologically into like the evolutions, indeed you had Shamir secret sharing. Shamir secret sharing is one primitive that is commonly used within MPC protocols, and it has a trusted dealer. That trusted dealer will indeed cut in pieces the key, and then distribute them. But at some point in time, you had a single point of failure. The key was actually within the reach of anyone, right? It's readable. It's there. You can hack it, and there's a game over risk at some point in time. So that's why Shamir secret sharing is less preferred to MPC. But what's interesting is that we actually use. So what I said is that you use Shamir secret sharing within the MPC protocols. What happens is that the key shares, or what we call in literature the partial keys, will be created by multiple trusted dealers. So this is what's interesting. One could think of it like Russian dolls, right? Like you have actually here. This is one partial key. Alone, it cannot do anything. You can't sign a transaction. You can't generate a wallet. You can't even harm the system with only one. But you have one trusted dealer that actually will have what we call subkeys. So like you'll have actually partial keys of partial keys for each partial key. So there is a single point of failure here actually, but only for one partial key, and there's another single point of failure here, but it's the consequence of hacking that single point of failure, that trusted dealer for one partial key, is to access one partial key. And that partial key, not a problem if you hack it, right? Because it's not good, but the fault, the error resilience, the attack resilience that Thibault was mentioning lies precisely in the fact that you have this threshold mechanism. You can even bring it to 5 out of 10, 15, 50 out of 1,000, etc. And so now you're forced to, if we think of an attack scenario, you're forced to actually grab all 3 in a moment, right? Because what's also interesting about threshold cryptography compared to multisig, for instance, is that you have key share refresh. You actually have key share repair, key share refresh, and key share rotation. So key share repair, refresh, and rotation. So in the literature, repair will be all these 4 will come together to repair only one.
Yeah, like if you lose one, repair basically...
Or one gets stolen?
Or, if you basically... So repair is like if you lose one, you can repair it, you can recreate it, because you still have like enough to regenerate this one.
Yeah,
now,
but it's going to be a new one.
It's going to be the same one, since like we didn't change these ones. I think I'm not exactly sure about this, but like point being that at the end you're going to have a key share that's going to be usable in that network. The refresh is basically, okay, you have these 5 key shares. And now you want to say like, I want to rotate. Well, that's
refresh. Yeah.
Well,
so when you refresh,
I say rotate, but it basically means that I want to change all those key shares into new set of key shares. I'm going to like put 2, for example. that becomes 2, etc. And we delete that. So we generate this new one, we delete the old one, and now we have a new set of 5 new key shares that will be able to sign the same way the old key shares were able to sign, for the, corresponding to the same, private key, so the same wallet. The advantage of this is, this is helping to counter an attack, which is basically, if we do that on a frequency time t, or frequency f rather. Let's call it t. Like at t1, we have like key shares 1 throughout the network, and at t2, we have key shares 2 throughout the network because we refresh those. If an attacker at t1 was able to get into signer 3, 4, 5, signer 4 and 5, and was able to steal those 2 key shares, he still needs to steal 1 key share to be able to reach the threshold 3. And if he does that, essentially he has stolen your wallet. But now, depending on the frequency, like it's hard to hack and get into the servers, because it's like assuming the hacker actually succeeds in doing that, which takes a lot of work and effort and everything and time. And so if he actually steals this one and this one at T1, and he succeeds to steal this one but later, so at T2, now he's going to have 2 key shares of T1 and 1 key share of T2, which doesn't work together. So now even
because
though
we did the refresh.
Because we did the refresh. So now even though he has now 3 key shares, the hacker has 3 key shares, they don't correspond with each other because we refreshed them, and so now he cannot hack into and get your funds and steal your wallet. So that's one of the main advantage of like key refresh, which is one thing we do. And last thing is key rotation, and this is more simple. It's basically like all the funds that you have on. It's just basically taking all the funds you have in one wallet and putting it into another wallet. So it's literally like changing the wallet. So it's using a different key shares, but that represent another wallet. So it's
another way of saying it is that key share refresh will sanitize and refresh the private key shares, but will not delink the new private key shares from the public key and the public addresses.
Right.
Which
it will not change the wallet essentially.
Which it can be very disruptive in business processes, but the rotation will change also the public key and the public addresses, which can be disruptive. So you do have rotation with multisig as well. It's the key share refresh part, which is very interesting. And also there is different, I would say, approaches and thesis about how often the frequency of a key share refresh. So Coinbase will, for instance, tell you that they refresh at each signature of each transaction. But then when you ask them like what you do with the key material that has become obsolete now, that has changed epoch, as we say in the literature, they'll tell you we just delete it. But how, like, that's important, right? Because you need to delete that securely. How do you prove that you deleted that securely? That's the whole thing. And how do you manage? Because who can say to me that who can prove to me that my engineers did not copy paste that and kept key shares on the side even though we deleted it, etc. That's a whole problem per se. So we kind of want to pay attention to that part as well. And secure key deletion is a hard problem. And the frequency at which you do also kind of expand the quantity of the key material you now have to handle and worry about, because there are attacks that are possible. You can reuse like the number, the threshold. If you get the whole, if you get 1, 2, 3, so the threshold at T1, you can still kind of reuse that those key shares to sign undesirable transactions. So that's a tricky kind of part, because it doesn't Thibault mentioned a situation in which indeed the refresh happened at the moment when the attacker only had 2 key shares out of 3. What if an engineer, for instance, a root engineer within Dfns or one of our, or a collusion between our node partners were to actually have all 3 key shares on T1? That becomes a major issue. So secure key deletion is a big part also of understanding MPC and making it secure. Yeah.
Okay, makes sense. So now I think we have established like what the
core
engine is, right? Like now, how can you explain us a little bit about how this makes its way to the developer interface or the user interface, right? Like how is this exposed to the external world?
Yeah, well, so like you said, this is the core of our product, of our offer, of our technology, and this is not really something we show directly to the user. So what's shown to the user is very simple. It's just an API, right? Like a web API. And so users can use can generate wallets very simply and use wallets just using our API, right? Like so Dfns. Okay, so yeah, in order to reach our API and to communicate with us and send, like I said, send post requests to us and request to our API to make a transaction or sign or something, you need to sign the request that you're going to make with a set of credentials. That can be different kind of credentials, but like we advise to use WebAuthn credentials, which are a set of credentials that are going to be tied to your user to your like fingerprint or to your face if it's a Face ID with your iPhone, and this credential will be kept in the secure enclave of your MacBook, PC, or phone. And whenever you're going to reach us, you're going to have to sign with some kind of key, and this key will be either showing your face on your iPhone. Or something like this with WebAuthn. WebAuthn, for those who don't know, are like I already said, a web standard. Everyone can check it out. It's a very powerful and secure web authentication standard that we leverage as well. And yeah, you could wonder why then the user doesn't just create a public-private key pair on his machine like a MetaMask and then use that to be his wallet on the blockchain directly. Well, the advantage of having WebAuthn credentials, but not directly your wallet credentials in your browser or like kept by you, is that those credentials now we can refresh them, we can change them, we can revoke them, we can change the permissions associated with them. Our API also have like policy capabilities, so like you can say, hey, I want this user to be able to do that, but not that. We want this wallet if there's a transaction of like above a certain amount, then 2 other people need to approve that. Those kind of rules. So we call them policies in our system, and so all that is possible now since like we actually hold the blockchain keys, and on your side you have credential keys, which are used for authentication, but just for authentication, not actually signing blockchain transactions. Yeah, so that's how our authentication works, and then communicates with our API, and then in our system, we communicate with the signing network that we showed previously, basically.
Okay, thank you. So in general, like there is a perception, I mean, it might not be correct, but there's a perception that, like MPC can be slow or, like low on performance, right? Like, so how do you manage that? Like what configurations that you've taken in your architecture to optimize for that, right? Like, I mean, so for example, I think we talked previously that, like you're following a 3x5 kind of configuration. So like just a little bit about why did you arrive at that, and like also maybe end on like a comparison with the multi-sig, right? Like I mean, because multi-sigs can be like you can increase that to a large extent,
Okay.
So some reasoning around that.
On-chain multisig, you mean?
Yeah.
Or okay. So first thing, on-chain multisig is even slow. It was way slower just because it's on-chain, so it requires the chain to and the consensus to move on and the blocks to be mined and everything. So on-chain multi-signature is definitely one way of like doing multi-signature. It's just very slow and does not fit most of our customers' needs are like based on a higher frequency, high frequency trading, or just like they don't want to bother or they don't want to pay gas fees to sign something, right? So that's what happens with on-chain multisig. This is an off-chain process, so you don't get paid for gas fees, but you still have like exactly like you're saying, the challenge of like how do you make it fast? Is it fast or is it slow, and how do you make it faster? So there's many parameters we can play with to make it more efficient. Well, first obvious one is like the TSS parameters, the threshold signature scheme parameters. You can play with those numbers, like how many what's the threshold you choose, what's the number, like the distribution of like how many signers you choose. If you choose like for example, let's say 100 out of like 500 parameters, then you have to make 100 signers talk to each other many times before you actually reach a signature, which makes it even longer. So obviously, like you have to find the right balance, which makes sense as far as security, but which also makes sense as far as like not unnecessary or false security and unnecessary latency in the system. So in our system, like we chose a 3 out of 5, and we also allow our customers to customize that if they want to, but like that's what we use. So you play with this. You also play with obviously the networking layers behind amongst these nodes, which you need to optimize. And we're talking about the latency that happens when these signing nodes talk to each other, but there's all the latency that you can also improve in all the API call or microservices that talk to each other for business logics or for policies, permissions, all that stuff. So we work on the whole chain to try to optimize the time. But as far as just the MPC part, so yeah, like I said, there's the TSS parameters, there's the algorithms that we use. So we formerly built on top of the GG18 algorithm, TSS algorithm, and now we're moving to a new algorithm, TSS algorithm, which is called CGGMP. I won't be able to tell you a lot about it because I'm not the guy to talk to about this, but it does increase performance to use that new technology, that new algorithm for MPC. One thing which is part of this algorithm, which is possible with this algorithm, is also to do pre-signatures. So now you can, during the idle times of the signing network, you can pre-generate signatures so that when you actually have a user that needs to sign something, so make a transaction on the chain, so you like 90% of the work of the TSS is already done, and you just need a last part. It doesn't compromise on security, but it increases the time. So obviously it needs a lot of work on our side to coordinate all that, to pre-generate the signatures and make the whole thing work. But this is a big increase also in performance and latency when you want to sign. And so yeah, so all of these are examples of areas where we can try to make it faster. But to give you like rough ideas with this setup, in our MPC network, and CGGMP protocol that we're using now, like we reach very like, and I'm talking about the latency of the whole chain, of the whole chain, not just the MPC part, but like we can reach below 20 milliseconds signatures, and also like key generation, so like key distribution. So it starts to come closer to what we're used to as far as like latency when you sign something. It should not be like above a second, and it should scale as well. So that's what we're working on.
Okay. No, certainly makes sense. In general, I mean, like zooming out a little, right? Like and going at the industry landscape, right? Like so, you have this constant tension between, like on-chain multisigs and account abstraction, and like off-chain MPC, like key management, right? Like, so what is your take on that? Like, do you think
where this is going?
Where this is going? Yeah. What are your thoughts on this?
So, I mean, I can answer a bit. Maybe Chris can give his view, but my take on this is that there's not going to be one solution or I still don't see one solution being the optimal solution for everything, and it really depends on the need of the end user or the customer. Some people will opt for would rather opt for like on-chain multisig or on-chain as account abstraction, but some people will want to avoid all the fees, avoid all the latency of blockchains to go faster, and it really depends on the use case and the balance between security, latency, and use case of their end users. So I think there's a place for. I mean, my take is that there's a place for different solutions out there. It's definitely very interesting for us to follow what's going on in this field, like where this is going, what's the new technologies on-chain or off-chain about it. Our take for now is to improve this off-chain MPC process, which we think and which we actually see like a lot of customers are interested in because they are happy to use our product and they want that. Otherwise, like I cannot really read the future. I don't know like if this is going to be converging into everyone's going to go to account abstraction or not. It's very hard to tell. I don't know if you have any other opinion on that, but that's my take.
Yeah, I would double down on that. I would say also that it's the early days. The ERC was published in April, March, April. So still very early. I mean, the observations, the conclusions are very early still. We need to kind of see ERC 4337 deployed, used, to see the limitations, understand everything about privacy. So now you're exposing much more data through the addresses. You can kind of guess a lot of more things than before. If you would imagine a world of applications using only AA. The regulatory aspect, the regulatory status of account abstraction, who is now the custodian. Companies like Argent would say that it's non-custodial, yes, but the developers that have access to the smart contract code and can potentially upgrade, aka swap a smart contract from one to another, if they are building an application that is intended to onboard users that and that they claim that that those users should be in control of their own money, etc. How does that look like? How is it set up? Gas fees is going to be interesting to watch as well in this new configuration. At the end of the day, you still have again like the key to access the smart contract. So what you do with that key, how do you secure that one? In that sense, and this is starting to become an industry-wide consensus, like MPC usage of MPC and key sharding mechanisms, which are more secure than just storing them in HSMs, even though those are secure enclaves, is complementary to AA. AA is also only an Ethereum thing, right? So we chose to be off-chain and API first because we wanted to be multi-chain. So I think that's another kind of assumption on our side. So yeah, all these kind of questions still in the air, still interested in understanding how it's going to play out. Yeah.
Cool. So I mean, in general, critics of like off-chain approaches like MPC, for example, right? Like I mean, they tend to kind of focus more on decentralization or self-custody, like more like a sovereign kind of approach, right? Like, but do you think that is the only audience that people should be catering to? Because as you said, there are also enterprises, there are also like complex hierarchies, like not everyone, you cannot give everyone a Ledger Nano, so how do you look at that perception?
So how is the question how our technology and how our architecture answers to the custodial discussion, the non-custodial discussion, and like how it's qualified, etc.
Yeah, and also what customer segments are you prioritizing for?
Yeah. I think the first thing is that we're mixing up two discussions most of the time in that discussion. When we talk about custody, non-custodial, co-custodial, self-custodial, we're talking about a very regulatory term. We're using regulatory terminology in a very philosophical way, technical way sometimes. So most of the time, it's what a crypto native developer will want to know is like who has actually access to the keys. The private keys, which is a great question, but it is true that, for instance, if you take the European regulation, you're not necessarily considered as a custodian if you don't have access to the keys physically. You're considered a custodian if you're in control of the keys, which opens up the whole landscape of APIs and being able to controlling the key at distance and not necessarily having them on-prem physically in your basement, right? So that it is the European regulation in Europe, for instance. It's going to be the US regulation in the US that is going to say what is right or wrong, that is doable, feasible, not feasible for businesses in crypto. Less like what the Ethereum Foundation thinks and believes. So it's also like that's the first kind of point, like separating the regulatory aspects from the technical and the philosophical ones. Now, when it comes to our model, because key share 1, 2, 3, 4, 5 is supposed to be not in control of the fence, but external parties. Most of the time, permission vetted parties that have compliance in place, that have high level of certifications, data centers with proven availability, 3 nines, and security controls all around that. We should not be able to do anything but to potentially kind of collude with all of them. If you think about companies that are telling us like, please, we want the key shares, and us complying with that, we would have also to collude with that company. So it's how do you? The question becomes what is the custodial qualification of a decentralized key management service? That's a difficult question. If you've talked to the top tier regulatory lawyers today in the world, they will tell you that there is no liability regime for such a network. No one knows actually. They would potentially go as far as to say that it's the whole network that is responsible if there's any problem, like there's some kind of shared liability around it, because yes, node 1, 2, 3 cannot do anything on its own, but if they colluded together, perhaps it's the whole network. Perhaps they will say that defense, because we built the network, we're responsible for it. It's a tough question, but at the end of the day, At the end of the day, our aim is to make sure that there is the surface of trust, the window of trust is as reduced as possible, so that if collusions happen, they are extremely complex and difficult to happen, and ideally, it is true that if we can also have an extra layer of like not only having the key shares geographically distributed, typologically distributed, not the same cloud providers, not the same external, not the same parties, not the same companies, same organizations, different people that don't know each other. Anonymity on this network is also an important aspect. If we can ensure that, but also add an extra layer of cryptographic controls, because all of these are necessarily secure enclaves, you have multi-sigs in front of them, and you distribute keys to customers so that they need to kind of authorize if you want to open up a secure enclave and access the keys. Well, suddenly you add this extra layer of trustlessness that makes the system even less like custodial. So that's what decentralized custody is all about. That's what decentralized key management service is all about. It's trying to add those layers of approval, cryptographic monitoring to make sure that undesired actions are not taken without the consent of the final owner. So ideally, this whole flow from API to key management network is just one big flow that is cryptographically controlled by either the company that is custodian and that has actually a license and the trust from its own users, asset managers, hedge funds, etc., giving funds to the custodian. And so custodians have the access, the controls to, this complex yet very stupid kind of signing box and key generation box, or the end user, because the platform in the middle, say, I don't know, a neobank that doesn't want to be custodian, wants to make sure that the end user has, when sending a Bitcoin from one place to another, has the cryptographic controls, and nothing in between all of this can actually interfere with that cryptographic control.
On the market segment that we target, like you asked, the path we take in the beginning is to say, okay, we're not going to target those people who already are very familiar with blockchains, who have a wallet, who really want to be self-custodians, have their Ledger Nano or MetaMask or whatever. Our take is to try to think to bring Web3 and wallets to the masses, and the way to do that is not us going to the world. It's us going to helping businesses to give users wallets very easily. If you're a business, if you're a small, medium business that's starting out in Web3, you're going to eventually want people to have wallets, and you're not going to want to, buy a Ledger Nano for everyone and send them this. Or maybe you don't also want to buy Ledger Nanos or whatever and keep them yourself and handle them yourself, manage them, secure them, the whole thing. So you want to really quickly have access to a way to provide your end users with wallets in a way that's like where you're used to do this. And the simplest way to do this is just to have a service that does this. And obviously, by saying this, we do take the position and the stand in the beginning, as at least that the key storing and management is going to be on our side, and the end users using services of companies will not even know that they're using a Dfns wallet. They're just going to be using a service. But they're going to have a wallet that's hosted at Dfns. But we think it's one way to bring wallets to the masses more quickly and more broadly. Yeah. And obviously it does take a stand on okay, this is the network, it's us, but really we're making a bunch of things so that it's not really even controlled by us, because it's going to be on a network of partners and everything like he mentioned. But without even going there, this is a first stand we take, and the businesses, so our customers are businesses, so we're primarily doing B2B today, and those businesses want to get started quickly with wallets, provide wallets quickly, easily, so that's what they do. But some of them tell us, oh, we don't want to be, legally responsible for our customers or liable or custodians somehow from a legal perspective of our end users' wallets. So we want to be the business, so our customers, they want to be the businesses that run the show, but don't want to be legally custodian. And so we also provide them ways so that they're not in control or in full control of their end user's wallet. So they can create a wallet for their end user, but once it's created, we call this delegated signing, but basically we have like a whole a setup where like we have the end user create credentials directly with us and stuff like this. And at the end of the day, our customer will be able to manage, so create a wallet for its end user, but it will never be able to initiate a transaction on behalf of its end user. It will always need the end user's signature in order to perform it. So now this is a configuration which we call delegated signing, which allows us to tell our customer, don't worry, like you're running the show using our product, but you're not legally responsible. Your end user is, because he's the only one who actually is cryptographically able to use his wallet and make a transaction.
No, there's so many more complex stuff to talk about, right? Because the UI can be malicious. The Robinhood, like turn off the button, sell button stuff. What about key recovery, disaster recovery on this side? But also, I'm losing my credentials on that side. What happens in that case? So fortunately, we have answers, and we're putting a lot of thought into all of this every day. But yeah, there's a lot to it. At the end of the day, we decided to build it this way because blockchain technology has irreversible risks, and we want to create enough buffer to reverse those irreversible risks and make sure that human errors can be possible without suffering the ultimate punishment of losing all your assets. Right? That's kind of the goal we set for ourselves, and we think that kind of that added softness, because it's some kind of softness that we're adding to the entire industry, the entire system, is what is going to bring more people, and it's going to bring more mass adoption, right? Because people that actually are not security experts will be able to join Web3. Yeah. Okay,
makes sense. I think we'll just wrap with this question in terms of so you mentioned a little bit about how what is there on your future roadmap, but maybe you want to share what other exciting things are there on your upcoming roadmap.
Yeah, sure. Secure enclaves are for sure one of them. Not only putting the auth system within the secure enclave, not only putting key shares in secure enclaves, but also making sure that ideally this KMS becomes composable and modular enough that it can not only, of course, the custom work of deploying in an environment, in a data center, on a cloud environment that we have never done before. That's work from us, right? But if we're thinking like automated self-served, the automated self-serve product, the cool stuff would be to kind of have templates, regional templates, different kind of templates of key deployment schemes. So Swiss regulators wants everything on Swiss soil, right? UAE regulators want everything on UAE soil. So that's interesting. And then you have people with less concern about speed and cost efficiency, more concerned about security. Then you can have, like Thibault said, the threshold scheme that is like 7 out of 20 or 20 out of 50. It's going to be more expensive for sure, slower, but it's going to be more secure to some degree. Then you can imagine, like we did, putting key shares in satellites because you're afraid of certain terrestrial attack vectors that you want to avoid. You can have a mix. So the composability of that KMS is definitely something we're striving for. Not only for security reasons, you kind of don't want to make sure that an attack vector can be replicated across different nodes, and so the diversity of the secure enclaves, the environments, helps to kind of build defense in depth and trenches, but also regulatory adaptability, right? So that is one thing on our roadmap. The developer experience is extremely important in all of this, because even though we have two, even tomorrow, like Thibault talked about face scan and touch ID. You can also use with WebAuth and PIN codes and YubiKeys and other means of authenticating. The final point is that you have in the secure TPM of your laptop, your phone, a key that is generated, and you access that key, and without that key you can't ping the API. No one in the middle can ping the API, no platform, etc. That 2FA, potentially tomorrow 3FA, can be sometimes cumbersome to implement, to install, to use, etc. And so just reducing the number of steps to make sure that we have top-notch security with just an Apple Pay kind of experience, that is also on the roadmap and like a general goal. We are concerned by the fact that defense can disappear, right? So we're thinking catastrophes, disasters. What happens if this disappears? What happens if that disappears? Redundancy, the audit logs, making sure that no root engineer within defense can. And ultimately, if ever we're talking to Hedera Hashgraph for their DREC protocol, decentralized recovery protocol. Delegating recovery is interesting to us because you kind of want to offload from your shoulders all the responsibilities, all the recovery processes, so that if defense disappears, well, you don't need defense. It's a contingent component in your stack. Those are things where we want to put in place. Ideally, and this is kind of the ultimate, I would say, this is the ultimate holy grail, right? Like a decentralized on-chain KMS would be beautiful if it could actually tick all the boxes of scalability, speed, cost efficiency, privacy, functionality, multi-chainness, etc. Today, that is yet to be. We've heard of, we look at the market, we see a bunch of they call themselves L2s, they call themselves MPC decentralized networks, etc., etc. The difficult part in all of this is actually this, right? And it's a bit like a marketplace like Uber. It's like Ethereum. It's all about the incentivization. Like, how do you incentivize a node to, in our case, generate a key share, maintain that key share, sign on behalf of it, be there when shit hits the fan, and what is the kind of revenue you need to give them to make sure that, so it can be economics. In our case, it's economics, not tokenomics. Could be tokenomics, but like, how do you structure that economically so that they keep on? You have like guaranteed security and availability and participation. That's the hard part, and I think that's also the hard part for a lot of these networks out there that are trying to tackle this very ambitious project, to nail that and create enough incentives. Yeah.
So, do you have any last words for this session? Like, did you have fun in general? I mean, I thought it was very informative in general. Any last words that you want to say to our audience?
Yeah, sure, please. You want to say last word?
Well, just thank you for having us and explaining what you guys do. It's very interesting as well. Like, you should check it out, guys. And go check out Dfns as well. We have a website. You can, if you're a developer that wanna have wallets very easily and securely, like, just check us out.
Yeah, maybe you can write down the website name.
We're rolling out in Q4 our self-service API. So the goal is to roll out a plan that's going to be very affordable. And make sure that everything can be, a cluster can be provisioned, and you can start working using our SDKs and work without human interaction, so self-serve. That's coming up. That's going to be exciting because we expect to create our first developer community this year.
Okay, awesome. Okay, thank you. Thank you, Chris. Thank you, Thibault.
Thank you very much.
Okay.